Understanding linear equations is fundamental to understanding algebra. As such, linear equations are heavily tested on the ACT. Let's review a couple different ways that linear equations can be represented. First, we have slope-intercept form, which is probably the most helpful to understand. Slope-intercept form is y equals mx plus b. We like slope-intercept form because it very easily tells us what the slope of the line is, m, and what the y-intercept is, which is b. Oftentimes, to solve a problem that has a linear equation, we will have to convert whatever form we are given into slope-intercept form in order to easily figure out the answer. Point-slope form, which takes on the form y minus y observed is equal to m times x minus x observed, is useful if we know the slope of a line and a single point anywhere on the line. Likewise, if we know 2 points on the line, we can calculate the slope, and then we can pick one of the points to plug in for y observed and x observed. Standard form looks like ax plus by equals c. Alright, let's do some problems. Write an equation for the line that passes through points 2, 2, and 7, 3. So in order to do this, we're actually going to first figure out the slope. And if we remember how to calculate slope from the slope video, we simply take the y values and the x values and find the difference between the two y values over the difference between the two x values. So we're going to do 3 minus 2 over 7 minus 2. And that's going to be equal to our slope. And of course, that's going to be equal to 1/5. Now that we have the slope, we can plug in either one of the points, so we can choose 2, 2 or 7, 3, it won't matter, and plug that into the point-slope form equation. So let's use 2, 2 for simplicity. So y minus 2 equals 1/5 x minus 2. This here is a perfectly valid answer to the question. We know, of course, that the answer that we get when we do our calculation by hand may not necessarily coincide with a multiple choice answer on the ACT. For example, they may have chosen to use the point 7, 3, in which case they would get the equation y minus 3 equals 1/5 x minus 7. They also may have chosen to rewrite this entire thing in slope-intercept form or even standard form. So let's solve this in slope-intercept form. So what we're going to do, we're going to rewrite this. So y minus 2 equals, we'll distribute the 1/5, 1/5 x minus 2/5, and then we'll add 2 to both sides. So y equals 1/5 x plus 8/5. And this would be slope-intercept form, which again is very useful because we have the slope and now we know what the y-intercept is as well. Let's look at the next question. Which of the following are equations for the line shown in the graph to the left? This is a classic linear equation problem where we're given a graph and a line, and we're simply asked to determine what the equation for the line is. So let's solve this. So first, it may be valuable to figure out what the slope of this line is. So let's find a few points on the line that are very easy to determine. So here's one here. It is -2, -7. Here's another one that looks like it is integer values of x and y, -1, -3. Looks like we have a y-intercept of 0, 1 right here, and then another point at 1, 5 right up here. So now to get the slope, we can just simply do rise over run for any of these points. So let's just do from the bottom for simplicity. So we go up 1, 2, 3, 4, and over 1. So we know that the slope is equal to 4. We also have the y-intercept. So y-intercept is equal to 1. So from that, we can actually see that A is a valid equation because we have y equals 4x plus 1, the 4 being the slope and the y-intercept being the 1. So A we know is correct. What about B? Well, we can actually determine if B is correct in a couple different ways. One way is we can rewrite this entire equation and solve for y, in which case we would simplify and we would see, if you want to go through the algebra, it would actually end up being y equals 4x plus 1. Another way to do it very quickly is you can test, since we know that we have a point 0, 1, we can actually test the point 0, 1 in this equation and see if it works. So we have negative 6 times 0 plus 1.5 times 1, and that does in fact equal 1.5. After we test one point, all we need to do is either determine the slope of this line and see if it matches to 4, or test another point. If we test 2 points and it works, or 1 point and the slope and that works, then this is a valid equation as well. So let's do the slope. If you have an equation written in standard form, like this one, the slope is just going to be negative a over b. So negative 6 over 1.5 does in fact equal 4. So we know that b is also a valid equation. Let's look at c. C looks like it is written in point-slope form. So we have the point negative 2, negative 7 plugged in here. And we can see on our graph that negative 2, negative 7 is a point on the line. And we also have the 4 for the slope. So knowing that we are choosing a point that's on the line and the slope that is equal to 4, we know that C is also a valid equation. Finally, we have another equation that does look like it's written in standard form. This we can actually very easily solve for y. We would just add 4x to both sides, and you'll realize that that would give us y equals 4x plus 1, which is exactly the same as a. So E, all of the above, is going to be the answer. All of those are equally valid equations for the graph of the line. Let's do the final question. What is the y-intercept of the line with a slope of negative 2 that passes through point 5, 1? So let's write this in point-slope form, because we are given a point and we are given the slope, so that seems to be the most logical way of approaching this. So y minus y observed, which is 1, equals m, which is negative 2, times x minus x observed, which is 5. And then we are going to solve for y, and then we will have that in slope-intercept form, and we can very easily then determine what the y-intercept is. So let's distribute the negative 2. So y minus 1 equals negative 2x plus 10, and now let's add 1 to both sides. And that will give us y equals negative 2x plus 11. So the 11, we know that y equals mx plus b. B is our intercept. So we know that the y-intercept is equal to 11.